Yeah. Now, before explaining the PDM diagram, I will just tell you the basic things involved in the PDM diagram. First, you have to draw a box, rectangle like this, and then first divide it into two halves, and then draw two horizontal lines so that there are 6 boxes, 1 2 3 4 5 6, and the top left corner box will represent the earliest start time. You can write it as, you can just write it as E S. Okay, and the next box represents earliest finish. You can just write it as E F. Okay, and at the bottom down, it represents it represents the latest start. You write it as LS, and the last, this represents the latest finish time, so you write it as LF. Okay, we'll stop here. We'll continue in the next. Yeah, continuing with the previous session, now we will see how to find the earliest start time for the box culvert in this PDM network diagram. See, first what you have to do is, based on the conditions, you have to draw this network diagram. So first activity is A, draw the rectangular box, write the activity code A, enter the duration as 1. Next, activity B and A are there. So for activity B, A is the predecessor and the relationship is finish to start. So you can put an arrow like this, okay, and then you can draw the rectangular box, okay, and then divide it into 6 parts. In the middle you write the activity code, that is B, duration 1. Like that, similarly you draw all the boxes, mention their activity code with the along with the durations, and it will be, if there is a space constraint, you can draw it down also, okay, like this, and you can move, you can see all the activities here, okay. So this is how you have to draw the network diagram, and if there is any other condition, you can just write it on the top like this, okay, Fs minus 1, Fs plus 14, Fs plus 14. So I will stop here. Continuing with the previous session, I will just show you how to calculate the earliest start and earliest finish time for activities A and B. See, for activity A, or the first activity of any project, the earliest start time will be 0. It can be taken as 0. So you can enter it, that value 0, as the earliest start time of this activity A. How will you find the earliest finish time of activity A? Earliest start time plus duration of that activity. So 0 plus 1, that is equal to 1, and you can enter 1 as the earliest finish time for activity A. Now moving on to the next activity B. For B, A is the preceding activity and the relationship is finish to start. So in a finish to start relationship, the earliest finish time of the preceding activity can be taken as the earliest start time of the succeeding activity B. Now, in this case, here for B, only A is the preceding activity. In case you have two activities or more than one activities merging in this activity B, then you have to take the maximum. Okay. Now, we have only one activity. So, for B, I am taking the earliest start time as 1. We can enter it here. And the earliest finish time of activity B will be earliest start time plus the duration. 1 plus 1, that is equal to 2, and you can enter that value 2. This is the earliest finish time of activity B. I will stop. Now moving on to the next activity C. For C, the earliest start time will be, for C the earliest start time will be what? 2, because earliest finish time of B is 2, and the relationship between C and B is finish to start. So earliest start time of C will also be 2. So you can enter that same value or number here. Now moving to the next one, earliest finish time of activity C, that will be earliest start time plus duration. That means 2 plus 1, that is equal to 3. So you mention that value or number 3 as earliest finish of activity C. Moving on to the next activity D, earliest start of D will be how much? 3, because the condition is finish to start. Okay, so write 3, and earliest finish of activity D will be 3 plus 1, that will be equal to 3 plus the duration 1, that will be equal to what? 4. That you can write here 4. Okay, I'll stop here. Yeah, moving on to the next activity E, I will just show you how to calculate the earliest start and earliest finish time for activity E. See, when we see activity E, we have two predecessors. One is activity D and the other one is activity C. Activity D and C are predecessors for activity E. Now, moving in the forward pass, the earliest finish time of activity C is 3 and the earliest finish time for activity D is 4. Always in a forward pass, when two activities are converging in a node, okay, we have to take the maximum value, right? So 4 is the maximum value, which is the earliest finish time of activity D, which can be taken as the earliest start time of activity E, and you can write this number 4 here. And how you will calculate the earliest finish time of activity E? That will be earliest start time plus duration, right? 4 plus 1, that is equal to 5. 5 will be the earliest finish time of activity E, that you can write here. I'll stop here. Yeah. Now continuing with the previous session, I'll just tell you how to enter the values for activity F. See, when we see here for activity F, there are two predecessors, activity D and activity E, and both the relationship is finish to start. Okay, so the earliest finish time of activity D is 4, whereas the earliest finish time of activity E is 5. So which one is maximum? In the forward pass, we have to take the maximum value, right? So 5 is the maximum value. So that value we take it as the earliest start time for activity F. And how you will calculate the earliest finish time of activity F? earliest start time plus duration. So 5 plus 2, that is equal to 7, and you can enter that value 7 here in this box. And moving on to the next activity G. So here for G, F is the predecessor and the relationship is finish to start, but there is a condition, that is finish to start but with the lead of 1, that is Fs minus 1. That means activity G starts 1 day before activity F finishes. That is the meaning. So 7 minus 1, that is equal to 6. So 6 is the earliest start time of activity G. So when you want to calculate the finish time for activity G, it will be earliest start plus duration. So 6 plus 1, that is equal to how much? 7. You can enter it here, 7. Okay, stop here. Yeah. Now we will see how to calculate the earliest start and earliest finish times for activities H and I. Coming to H, the predecessor is G and the relationship is finish to start. So the earliest finish time of activity G will be taken as the earliest start time for activity H, right? So you can just mention it as 7 here. The earliest start time of activity H will be 7. Now what will be the earliest finish time of H? It will be earliest start time plus duration. So 7 plus 1, that is equal to how much? 8. So you can enter that value 8 as the earliest finish time of activity H. Now moving on to the next activity I. Activity I, H is the predecessor, but there is a condition in finish to start. There is a lag of 14 days. Okay, finish to start plus 14. That means activity I should start 14 days after activity H finishes. That is the actual meaning. So you add 8 plus 14. You add 14 days with 8. 8 plus 14, that is equal to 22. So 22 will be the earliest start time of activity I, and that you can enter it here. When you want to find the earliest finish time, it will be earliest start time plus duration. So 22 plus 1, 23 will be the earliest finish time of activity I, that you can enter it is here. Okay, I'll stop here. Yeah, continuing with the previous session, now we will see how to calculate the earliest start and earliest finish time for the last activity J. Now, if you see, the predecessor for activity J is activity I, right? But there is a lag of 14 days. That means activity J should start only 14 days after activity I finishes. So that means 23 plus 14, that is equal to 37. So after 37 days only activity J should start, or the earliest start time of activity J is 37. I hope you understood. So I will write the value earliest start time of J as 37, right? 37. Okay. Now coming to the earliest finish time of activity J, it will be earliest start time plus the duration, that is 1. That will be equal to how much? 38. So that you can write here 38. Okay. Now the forward purse is complete. So I'll stop here and we'll continue in the next session.